So, hello and welcome to our next video on worked solutions to one of our homeworks. I'm looking today at the translation and vectors homework that I set for my year 7s and a version of this also for my year 8s. So this was the instructions. I want to read to you the very beginning of this where I've said, as lockdown continues, we need to start looking at material you may not have been taught before. So to begin with, I'd like you to log on to MathsWatch and look at videos 50 and 174. Take as much time as you need with these. And it's really important that you do that lesson, those videos, that learning before you try the questions. I appreciate it's a temptation to just start going, but in class, I wouldn't introduce something new and then say, just try some questions. I would talk through how we do it and then we would try it. So please don't be in a hurry. Take time with your learning. So when we come to MathsWatch, you'll see here a bunch of questions along the top, and you'll see that we have here some videos. You'll notice that I have some little balloons that are marked along here along the top, and this tells you that I have left you a hint. So for example, if I go down here, my hint was just this is a BidMaths question, or over here that this was, it said use a calculator. Remember, this is what it means, etc. And so I have all sorts of questions. Here, question 13, where we start the translation, and I've said make sure you've watched these videos before you start. So do look out for those hints. And again, if you aren't unsure, there's videos here on translations. Back in question 2, if you weren't sure about BidMaths, then there's questions here you can watch. They are there to help you. So we're going to start with question 1 and see how we get on. So here is question 1, and you will notice it's very similar to one we did in the previous homework, and I made a video of that, of those 12 numeracy questions. So we have coffee and waffle. We could have coffee and pancake. We could have coffee and toast. We could have matcha and waffle. We could have matcha and pancake. We could have matcha and toast. And then we could have latte and waffle. We could have latte and pancake. We could have latte and toast. And that's really how we're trying to find that order to these things. So hit submit answers. And there we go. All done. Number 2. Let's move on and see how we do with number 2. So we have some BidMaths. I have 32 minus 5 times 7. Well, I know that 5 times 7 is 35. So I'm going to write it out as 32 take away 35, and that tells me it's going to be negative 3. Second one, 3 times 8 take away 9 minus 3. I'm going to do a multiplication first, so we've got 24 take away 27, because 9 times 3 is 27. So 24 take away 27 is again negative 3. And then for the last one, I have a brackets there, so I'll do the brackets first. I have 1 plus 5 take away 8. Because I have a plus and a negative, or plus and a minus, I'll do them in order. So 1 plus 5 is 6. 6 take away 8 is negative 2. 4 times negative 2 is negative 8. And there we go. I don't know why it says whoops, I've got some incorrect answers, but they are all correct. Number 3. So we talked about prime factors. And again, we want here to go and look at our prime factor tree for 250. So with 250, I could start with 2, but I notice that 5 is a prime number, goes in rather neatly there, and that 5 times 50 is 250. So I'm going to choose to go that way. And again, I see we have another 5 there. So I'm going to have 5 again times 10. And what makes 10? Well, 10 is again a 5 times a 2. So it can tell me there that my prime factors is going to be 2 times 5 times 5 times 5. So let's stick that into MathsWatch. So there I've typed out 2 times 5 times 5 times 5, and that's what we're looking for. Question 4. The value of, well, we recognize, do we know what 6 little 2 means? It means squared. It means 6 times 6. It doesn't mean 6 times 2. It is 6 squared, which is, of course, 36. And then the other funny bracket, funny symbol, means the square root of 81. It means what times itself gives me 81. In this case, the answer is 9. Question 5. So we want to complete our table. 1/5 as a percentage. Well, there's different ways of doing this. I'm going to show you one way of doing that. So here you can see I've written 1/5. I've written something over 100. And I want to convert 1/5 into an equivalent fraction over 100, because that's what percentage means. So 5 times what gives me 100? Well, 5 times 20. So to keep it equivalent, I'll do the same thing on the top line. 1 times 20, and that will indeed be 20. So my answer should be 20%. Now I know as a decimal that 20% is the same as 2/10. So I'm going to write that as 0.2. 25%, well, as a decimal, that's just 0.25. Because that's the tens, that's the hundreds, so it's 25 hundredths. And I know that one, 25 over 100, I know it is a quarter. So I'm going to type 1 over 4, like that. And if I wasn't sure, I could write 25 over 100 and simplify down. But in the same way as I know a half is 50%, I'm just going to type those. And I know that the decimal is going to be 0.5. And then what about this one here? 66.6% or 0.666 recurring. Well, I know that 0.333 is 1/3. So it stands to reason that 0.6 recurring should be 2/3. And there we go. Number 6, we have some calculators here. So we're going to use 83 of 408. I'm going to try and use my calculator because I'm allowed to show you how we do that. So here I've got a calculator up on the computer. I want 83%. Well, I know that that is brackets, 83 divided by 100. Close my brackets. And that's, of course, as a decimal is 0.83. And it's of 408. So I'm just going to type times 408. And that will give me the answer, 338.64. Now I'm going to type it into MathsWatch in a moment. I'm going to do exactly the same thing for the other things. 41 over 100 times 53. 97 over 100 times 345. So you can see there I've typed in the values from my calculator, hit submit answer, and there we go. And we're on to question 7. So we're expanding some brackets here. I'm remembering that 3 times x plus 5 means multiply everything inside the brackets by 3. So 3 times x is 3x. 3 times 5 becomes plus 15. For part B, 4 times everything inside. 4 times x is 4x. 4 times negative 4 is negative 16. Part C, 2 times everything. 2 times 5x is 10x. 2 times 1 is plus 2. Oops, did that one wrong, didn't I? Try that one again. So we have 10x plus 2. And then finally for part D, 7 times everything. 7 times x is 7x. And then 7 times negative 9y. Well, 7 times 9 I know is 63, but 7 times 9y will be 63y, but there's a negative there, so 63y should look like that, and there we go. Going on to question 8, and we have some sequences here. And again, I'm going to remind you how we do these. So here I've done a table. I've got n as the nth term, so the first term, the second term, the third term, etc. And then my sequence, my general rule is 8 minus n. So 8 minus 1 would be 7, first term. 8 minus 2 would be 6, second term. 8 minus 3 would be 5, third term. Now I'm asked when the first negative term would be. So I'm just going to go ahead here. That would be a 4. That would be a 3. That would be a 2. That would be a 1. 8 minus 8 would be 0. But of course, it's not yet negative. The negative comes here, position 9. 8 minus 9 is negative 1. So that'll be my answer. 7, 6, and 5, the first 3 terms. And the first negative term at position 9 would be negative 1. Let's put that into MathsWatch. And there's my values, and there we go. And question 9. I'm going to change these into other things. So I know that 4,700 grams is going to kilograms. I know there's 1,000 grams in 1 kilogram. So to go from 1,000 to 1, I have to divide by 1,000. So I'll divide 4,700 by 1,000, which should be 4.7 kilograms. I'm going to change kilograms into grams. Well, I know that 1 kilogram has 1,000 grams. So to go from 1 to 1,000, I'm multiplying by 1,000. So I will multiply 9.65 by 1,000, and that'll give me 9,650. Kilograms into tons. Well, tons is less well known as a measurement, but basically there are 1,000 kilograms in a ton. So if I had 1,000 kilograms, I would divide by 1,000 to get 1 ton. So I know that I'm going to again be dividing 1,700 by 1,000, and that should give me 1.7 tons. And then finally, I have changed 3.2. Well, that T stands for tons. So 1 ton is 1,000 kilograms. From 1 to 1,000, I'm multiplying by 1,000. So in this case, I will multiply 3.2 by 1,000, and that should give me 3,200. And there we go. Question 10. Find the volume of this cuboid. Well, there's different ways of doing it. Essentially, I'm going to multiply them together. So it's going to be 10 times 8 times 6. Well, I'm not allowed to use a calculator for this one. So I notice probably the easiest way would be to multiply 6 by 8 first, which gives me 48. And then multiply the 48 by 10, which would then give me 480 cubic centimeters. Question 11. Work out the size of angle X. Well, I have a triangle here. I notice that in the bottom left corner is that square symbol, which tells me that I have a right angle. So that's 90 degrees. So I'm going to add 90 plus 43 and then take that away from 180 because I know that the angles in a triangle add up to 180. And when I do that, I work out that this angle here, X, must be 47 because 47 plus 43 plus 90 together would give me a right angle, give me 180. And then question 12, the last of our numeracy questions, we want to find a parallelogram. Well, this is an interesting one because I notice, if I look at B, going from B to C, it goes along 2 and then it goes down 5. Let's see if I can show that with my little thing here. So we start off at B, 2 to the right, 1, 2, 3, 4, 5, down. So if this is going to go like this and then like this, I'm going to start at A and go 2 to the right and go 5 down. 1, 2, 3, 4, 5. And so I reckon if I draw my X there, my coordinates should be here. Again, it looks like it is going to be a parallelogram. I'm not asked to draw it, but I'm asked for coordinates, remembering that they have to be in brackets. It's 0 along and 2 down, which we write as -2. And that is the end of our numeracy questions. So then we're on to our new stuff, translation. And again, if you weren't sure about this, then it's good just to pause and to watch those videos. So I have a triangle. I want to translate by the vector 2, -7. I've watched my video. I know this means 2 to the right and 7 down. So I'm going to start with this point here. I'm going to go 2 to the right, 1, 2. I'm going to 7 down, 1, 2, 3, 4, 5, 6, 7, and draw a point there. I'll do the same thing here, 2 to the right, 7 down, and draw a point just there. And then I'm going to go to the third point, 2 to the right, 1, 2, 1, 2, 3, 4, 5, 6, 7, and it should be just there. And now I'm going to grab my ruler and I'm going to draw these points here. Now, MathsWatch can be a little bit fussy about this, but hopefully it will accept my work. So there's the first bit. I want now to connect that point here to the next one, which is down there. So let's just draw that down there. And then finally, the third is going to be straight up. So let's just draw my ruler. So it's going straight up. That's about right there. Going to move that. So we're onto here. A little bit hard to see because of the axis, but that should be hopefully my triangle. So just get rid of that for a moment and we'll see if MathsWatch likes it or not. And it did. Excellent. So lots and lots of practice doing this. We're going to translate the shape by the vector -1, 5. I'm going to do exactly the same thing there. I'm going to take this first point. I'm going to go 1 to the left and 5 up. 1, 2, 3, 4, 5. Draw a point. And I'm going to draw all 4 points. I'll just do that quickly. So there I've drawn my 4 points. And I'm going to use my ruler to connect them all up. And I'll do that again very quickly. Now, if you notice here what I've drawn, I'm actually just missed the grid line just there. So I'm not quite at the very top where I should be. And MathsWatch can be fussy, which is why some students get rather frustrated with doing this. But in this case, I'm close enough and it has accepted my work, which is always a bit of a relief. So question 15, we have something new. It says invariant. And I made a comment there in the hints that invariant means a point that is not changed through a transformation. So I know that I'm going to move this by the vector 1, 3. So if I was to take, say, this point and move that 1 along and 3 up, it would stay the same. If I moved the bottom right one, it would move 1 up, 3 to the, it wouldn't stay the same. If I moved the top left one, it wouldn't stay the same. And likewise here, it wouldn't stay the same. I think basically everything here would be shifted. So my answer is probably going to be there are no invariant points, which is a bit of a funny question, really, I suppose. And let's have a look. And we were quite right. There are none. So I'm sure we'll have some more on invariance later on. Translate this shape by the vector 4, 5. So each point there, we're going to go 4 to the right and then 5 up. Let's have a look at doing that. And here you can see I've drawn 4 along and 5 up, and it should look something like that. And hit submit answer, and there we go. Question 17. Complete the vector to fully describe the single transformation that takes A to B. So if I was to take, say, the bottom right here, I'm going to count 1, 2, 3, 4 along. So I'm going to write 4 along there. I'm going to say how many down do I have to go? 1, 2, 3, 4, 5, 6. Now if I'm going down, it's going to be a -6. I'm just going to check that with a different point. I'm going to go to maybe the bottom left point, count 4 along, and 6 down. Does seem to be okay. And let's try that. And I've made a mistake. Can you see what mistake I've made? Perhaps you made the same mistake as well. It said from A to B. Of course, A is on the bottom and B is on the top. So actually, I want to go 4 to the left and 6 up. So I'm just going to change that to -4 and +6. And that's a really, really easy mistake to make, which is why I made it. And that's much better. Question 18. I'll try and get this one right. We're going from A to B. So we're going from the top right over to the bottom left. So if I take my bottom left point, I'm going to go 1, 2, 3, 4, 5 to the left. That'll be -5. And then I'm going to go 1, 2, 3, 4, 5 down. That should be -5. I will just check that from another point. Go to the top right. 5 to the left, yes, and 5 down. That does seem to work. And let's check that one. And we're getting the hold of translations. That's really good. Question 19. We have now some column vectors. Interesting. So here's a quick recap of vectors for you. Now again, this is very, very quick. I'm expecting you've gone through the video and try to make sense of it. I suppose I have a vector A, so it has a certain direction. This might be, say, as a column vector 2, 2. Well, if I had a vector in a certain direction and then I doubled it, I would end up going in the same direction twice the distance. That's the idea. Or if I had a negative A, that would mean I was going in the opposite direction, but the same sort of distance. So A going that way and a negative A going this way. This is the concept. And when we have vectors, we can add them, we can multiply them, etc. So if I have 2 lots of F and 1 lot of F is going 4 to the right and 1 up, then 2 lots of F will go 8 to the right and 2 up. But I can also add vectors. I can go, in this case, 4 to the right and 1 up, and then 5 to the right and 3 up. Well, basically all I have to do is 4 plus 5, which would be 9, and 1 plus 3, which would be 4. Looks a bit complicated, but actually it is quite doable. And then part C is a little bit trickier. What if I had 2 lots of F, that's at 8, 2, and then instead of adding a G, I went in the opposite direction. I went -5, -3. Well, 8 from 2F, take away 5 would give me +3. And 2 take away 3 would give me -1. Put it in the right place. Now that's a little bit more complicated, but if you want to look at the videos, I'm sure they'll go through that as well. So there we go. Question 20. I'm told that this translates from P to Q using the vector AB. What are my values? Well, again, I'll look at the top left coordinate of P. I'll look at the top left coordinate of Q and count how long it takes me. So 1, 2, 3, 4, 5, 6, 7 to the left, and 1, 2, 3, 4 up. So 7 to the left would be -7 because I'm going to the left, and 4 up would be +4 because I'm going up. It's written as algebra, but actually it's nothing different from what we've been doing up to now. Question 21. We want again to translate using the vector AB. We're going from P to Q. So if I take my bottom left value here, and I'm going to go from there to there, 1, 2 to the left, 1, 2, 3, 4 down. So 2 to the left is -2. 4 down is -4, and that's how it looks. Question 22. Now we have a multiple choice one here. So I'm told that R translates to S using the vector 4 to the left and 1 up. How do I do the opposite way around? How do I go from S to our R? So instead of going 4 to the left and 1 up, I'm clearly going to go 4 to the right and 1 down. So which of those is 4 to the right and 1 down? I think my answer will be D. And there we go. Question 23. Similar idea. We've got from P to Q. So if I go from the top right of P to top right of Q, I'm going to count my squares. I'm going to go 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 up. So 6 to the right and 3 up, and that hopefully will be right. Question 24, a very similar one. We're going to go from P to Q. I'm going to start at the far right. So I'm going to go 1, 2, 3, 4 to the right and 2 down. So 4 to the right. Now 2 down is of course -2 because up is positive. So down is negative. And there we go. And then question 25, we have here some vectors. Interesting. Now with this one, I've just done a little of a screenshot here, try to make sense of what we're doing here. We have vectors A, B, C, D, and E, and we're asked to express them in terms of A or B. Now A I know is going just 1 to the right, and B is going 1 up at a bit of a diagonal. So I look at C and I ask myself, how many A's would I need to make 3 to the right? Well, hopefully you'll see that that would be 3 lots of A. And I'll put that into MathsWatch in just a moment or two. C would be 3 lots of A. It's a 1, a 2, and a 3. But what about D? How do I get a D there? Well, I notice that that's like going 1 to the right and 1 up. If I did an A here going 1 to the right, and then I did a B there going 1 up, then I would get the same as D. So actually it's going to be A plus a B. And what about E? E is a bit of a tricky one, isn't it? E is going down. Well, I look at that and I say, well, if I was to go 1 to the right, which would be my A, just like that, try and draw a little arrow there if I can. How would I then go from here to there? Well, I know that going from there to there is a B, so going from here to here should be the negative of B. So A minus B is how I would do that question. And that's actually a lot more difficult, but it is question 25 on your homework. Let's put that then onto MathsWatch. So there I've entered the marks there, the answers, and if I hit submit, then that's happy with those. Now, if you are in my Year 8 class, you're done. Congratulations. My Year 7's had a few other subjects I'll look at with them in just a moment or two. But But if you're in my Year 8 class, I want to encourage you now to go back and look again at that homework, those first 25 questions. Now, you might be tempted to say, well, I'll just copy out Mr. Kane's answers, but that's just like copying someone's homework book. It doesn't advance your learning in any way. So by all means, watch the video, but then try it yourself. And if you get it wrong, try it again until you are confident that you are making progress. And for my Year 7s, we'll continue then looking at question 26. And here, it's a little bit more complicated. Think about our vectors. If I have G is 3 to the right and 1 down, then 2G would be 6 to the right and 2 down, but we're asked for a negative 2G. So actually, in the other direction, it would be negative 6 and positive 2. What about F plus 3G? Well, my top line, I would be going 2 to the left and then going 3 to the right 3 times. So that's like doing negative 2 plus 9, which of course would be 7 to the right. And what about going up? Well, it's like going 4 up and then going 1 down 3 times, which is the same as doing 4, take away 3, which would be 1. And then part C, a bit more complicated. 2 lots of F, take away 4G. Well, to be honest, I think this one I'll do by paper. So let's have a look then at our 2-column vectors. I want to find 2F first of all. Well, F is negative 2, 4. So 2F would be negative 4. It's going 2 to the left twice. And it's going to be 4 times 2, which is 8. So I can look at that. That's my 2F. 4 times G. I'm going to write just 4G. If you go with the negative for now. So 4 lots of G. 4 times 3 is 12. So that's 4 lots of 3 to the right. And then negative 1. 4 lots of negative 1 is negative 4. So what I'm going to do now is I'm going to take this one, subtract this one. If I was adding, it would just be negative 4 and 12, which would be 8. But I'm going to subtract. So negative 4 take away 12 should be negative 16. And 8 take away negative 4. We've got a little bit difficult with our negative numbers there. If I was 8 take away 4, it would give me 4. But I'm taking away a negative 4. So it's going to be the other way around. So it's going to be positive 12. And if you want to, you can use your counters for that. So negative 16 and 12. Let's take it in MathsWatch and see if we're right. And there it is. And it likes it. Great. Quite a challenging question. So well done if you got that one right. Question 27. I'm asked to write D as a column vector. Well, I see that going from the bottom of D to the top of D, because an arrow pointing, I'm going left, is going to be 2 up and 3 to the left. So 3 to the left is negative 3. And then 2 up is a 2. And then over here, H plus K, I can just add the top lines. So 4 plus negative 2, 4 to the right and 2 to the left will give me 2. And then 3 to the left and 1 to the left will give me a total of 4 to the left, or negative 4. Question 28. So D is going 2 to the right and 3 up. So it's going to become 2 and 3. And again, H and K, adding those together, I have 1 to the left and 4 to the right. Well, I just add those. Negative 1 plus 4 is 3. And then 3 to the right, so 3 up and 2 down. Well, that's going to be 3, take away 2, and that's going to be 1 up. So it should be 3, 1. And then our last question, question 29. And this one is quite a challenging question. It's very much an extension question. And I'm going to, again, put that onto paper and talk through how we would do this question. So here it is on paper. this is a question that I would not expect my Year 7 class to be able to do. Now, you might say, well, why did you put it in your homework, Mr. Kane? And it's because I have some students in the class who are finishing their homeworks ever so quickly. And so I have to give them some questions to stretch them. So if you look at that, you thought, I haven't got a clue, that's perfectly okay. But there are some students who will enjoy and indeed get hold of this. So it is a parallelogram. I know that this side and this side are the same length and they're parallel. This length and this length are parallel. I also know, because it's a parallelogram, that O here is in the middle of OB and OD, and O is the middle of OA and OC. And in fact, if I have a direction going down here of A, I know that this will also be A, because it's the same length and the same direction. And I know that this from D to O will also be B, because that is going in the same direction and the same length. So I'm asked to find vector C to A. How do I get from C to A? Well, I go to O first, which is an A. I then go to A, so it gives me two A's. So my answer there would be two lots of A. How do I find the vector A to B? How do I get there? Well, I can't go directly. I don't know what this one is, but I can go this route. So I can go from A to O and then O to B. Well, if O to A is a small a, then going in the opposite direction must be a minus a or a negative a. So this bit is negative a, and then that's a proper b. So my answer will be plus b. And then finally, vector BC, how do I get from there to there? Well, similarly, I'm going to go down to O, and then I'm going to go up here. So down to O is going to be a negative b. And then going this way, well, I'm going against the direction of A. A is going that way. If I'm going this way, that's going to be a negative A, and that should be my answers. Now again, that is really quite tricky, but it's an extension question, and I know some of you enjoyed looking at that. Let me just put that into MathsWatch. So there they are in there, and hit submit answer, and we have finished our homework. So 25 questions. Again, let me encourage you, if you're in my Year 7 class, go back and have a look at those. It's still open. You're welcome. Again, there's no value in just copying up my answers, but have a look and master this, because at the end of the day, I want you to be able to make progress in this. So thank you for working through it, and I hope that that was helpful. And again, any feedback is always very much appreciated. Thank you.